So today we're going to talk about shapes of molecules. This is something that usually scares off a few students, but it's pretty straightforward. Once you see this video, I think you should be able to figure this out. So there are certain things that you need to know and memorize to figure out the shapes. So for example, if you have a central atom and it is bonded to two atoms on each side. So this kind of molecule is going to have what is called a linear shape, and the bond angle is going to be 180 degrees. So this is basically 180 degrees. And the other kind is when you have a central atom which is bonded to three groups of atoms. Just bonded to three groups of atoms. So in this case, we're going to call it trigonal planar. And the bond angle is going to be 120 degrees. So this angle is going to be 120 degrees. This angle is going to be 120 degrees. This angle is going to be 120 degrees. So you add them all up, it's 360 degrees. So basically this is in a flat plane, like on a piece of paper. This is on a flat plane. And then the other kind is going to be when you have a central atom which is bonded to four other atoms. So four other atoms. So in this case, this is a three-dimensional arrangement. So when I'm drawing this, it basically means that it is coming out of the page, this guy. And this means that this guy is going into the page. So this represents a three-dimensional diagram. And this type of shape is called tetrahedral. And the bond angle is 109.5 degrees. So basically, the bond angle between each bond is going to be 109.5 degrees. Okay. So then we have something called, when you have a central atom which is bonded to five other atoms. So this is going to be this, this, and this. So in this case, this part here, I'm going to change the color. So this part is basically a triangle in a flat plane, like this one. So these guys are going to have 120 degrees of bond angle. So these guys have 120 degrees of bond angle. All right? And the one at the top and the one at the bottom there are just at 90 degrees from this flat plane. So this type of shape is called trigonal bipyramidal. Okay. And the bond angles are going to be 90 degrees and 120 degrees. So this is the trigonal part, and the reason it's called bipyramidal is because if you can imagine the shape, so you have this base. This is like a three-edged base, and then if you join these two guys with the top and this guy at the bottom, so basically you have two pyramids, one at the top, one at the bottom. That's why you have the bipyramidal. So two pyramids. And the other kind is called when you have a central atom that is bonded to six other atoms. So this is this, and this is at the bottom. So basically, like the previous one, these guys are like a rectangle, these four guys. These four guys are at a rectangle in a flat plane, and this guy's at the bottom, this guy's at the top. So each and every member is at 90 degrees from each other, even the top one and the bottom one. So this type of shape is called octahedral, and the bond angle is 90 degree. So here I have some 3D images for you to look at it. So this is the tetrahedral one. This is the tetrahedral one. So all the bond angles are 105 degrees. So it might be difficult for you to imagine, but this is a three-dimensional one because the bond pairs and the lone pairs of electrons, they repel each other. So they want to go to the maximum possible separation. So if they were in a flat plane, so imagine if you have four atoms, so like this guy. So imagine if this was a flat plane, if this is how they arranged themselves, the maximum separation they're going to get is 90 degrees, so which is not good. So that's why these guys rearrange themselves in 3 dimensions and in such a way that this is the maximum possible separation, 109.5 degrees. So this means that the bond angle between this guy, the bond angle between this guy and this guy is also 109.5 degrees. It goes all the way 109.5 degrees. The bond angle between this guy and this guy. So let me change the color so that I guess it's easier to see. So the bond angle between this guy and this guy is also going to be 109.5. So that's that. And this one is the trigonal bipyramidal one. So this is your trigonal planar shape, 120, 120, 120. And this is the one at the top, this is the bottom. So these guys make up your pyramid. So this guys make up your pyramid. So this is the one where you have, let me write the name, trigonal bipyramidal. And here you have the bond angles 90 and 120. So 90 degrees and 120 degrees. And this one is the octahedral one. So all the bond angles are 90 degrees. So this is pretty hard to see because I'm not really good at drawing, but once you see this, I think you should be able to figure it out that this forms the flat plane, these four guys. So if you imagine this is the plane, so this is the plane, this is the flat plane. So these guys have a separation of 90 degrees from each other. And then this guy at the top and this guy at the bottom, they're at 90 degrees to the plane, right? So all the bond angles are 90 degrees. So you need to know the name of these guys, these 5 basic shapes. You need to know their names and you need to memorize their bond angles. So once you memorize these bond angles, you can figure out almost any shape you'd be thrown at in A levels. So like I said, that these angles are between each bond pair of electrons, right? And electrons are all negatively charged, so they repel each other. So one other thing that I'd like to mention is that the repulsion between a bond pair and another bond pair is less than the repulsion between a bond pair and a lone pair, which is less than the repulsion between a lone pair and a lone pair. So this basically means that the repulsion between bond pairs are the least. So they repel each other the least amount. But if you have a lone pair present, so the bond angle should increase because they repel each other more. And the bond angle between lone pairs should be even greater because they repel each other the most. So in A levels, we don't care about the bond angle between bond pairs and lone pairs. So that's a good thing that we don't deal with lone pair, the bond angle between lone pairs, or the bond angle between a lone pair and a bond pair. We only care about the bond angle between bond pairs. So so another thing you need to memorize is that whenever you have a lone pair, so for each lone pair, I'm going to do an example and then it's going to be pretty clear. So at this moment, just remember this, that for each lone pair, the bond angle is gonna decrease by 2.5 degrees. Okay, so this is very crucial at this point. You should remember this. So whenever you have a lone pair, you know that the bond angle is gonna go down by 2.5 degrees. So these are the original bond angles. So if I have lone pairs, I'm going to deduct 2.5 degrees from each of them. So we're going to look at an example now. So before that, let's do a simple one. Okay. So let's find the bond angle in, say, CH. Let's do BF3. So the bond angle in BF3, right? Okay. So I know that there are 3 bonds, right? So before I rush into it and say that the bond angle is going to be, so it has, the central atom is boron, and it has 3F fluorines attached to it. So it has 3 fluorines attached to it. So it must be 120 degrees. This is trigonal planar, like this one. Trigonal planar, 120 degrees. Well, before we do that, we must use a precaution here. So we need to know that if there's a lone pair present in the central atom, the angle should go down by 2.5 degrees. So the thing is, if there's a lone pair present, then we have 4 electron pairs. So we cannot do this anymore. So it's very important that we figure out the number of lone pairs present. So how do we do that? So basically, we have a formula. It's pretty straightforward. So number of lone pairs, I'm just going to write LP, on central atom. So this is not carbon. So on central. So let's just call it CN. On central atom is going to be group number on the periodic table. So this is the group number of the central atom divided by minus number of bonds formed divided by 2. So if we look at this, hold on. Okay, so if we look at the periodic table, so we know that boron is in group 3, right? So let's go back to our problem. So boron is in group 3. So boron is in group 3 minus number of bonds formed. So boron formed 3 bonds. So minus 3 divided by 2, so this is 0. So there are no lone pairs there. So it's easy and straightforward. So now I know that boron has only 3 bond pairs. So if boron has 3 bond pairs, this is right. This is correct. We can say that, yeah, this is okay. This is fine. Now let's look at something else. Let's say that we are dealing with NH3. No, let me change color. Okay, so let's say that we're dealing with NH3. NH3. So now you might think that, oh, it also has NH3 and the nitrogen is the central atom, and it also has 3 bond pairs. So I can just say that this is also trigonal planar and the bond angle is 120 degrees. But, well, like I said, always check if there's any lone pair. So nitrogen is the central atom. So I'm going to check the periodic table again. So I'm going to check the periodic table again. So nitrogen is in group 5. So this is nitrogen. So nitrogen is in group 5. That's group 5. This is nitrogen here. So nitrogen is in group 5. So I'm going to use this formula here to figure out the number of lone pairs on nitrogen. So let's do it. Number of lone pairs on nitrogen is equals to group number of nitrogen minus number of bonds formed, the whole thing divided by 2. So 5 minus the number of bonds formed is 3. So that divided by 2, this is 1. So wait, we have 1 lone pair on nitrogen. Huh. So basically what's happening is the total number of pairs around nitrogen. You have 1 lone pair. You have 1. This is a bond pair with 1 hydrogen. This is another bond pair with another hydrogen. So this is how it looks. So, okay. So this is the lone pair. This is 1 bond pair. This is another bond pair. This is another bond pair. So in total, I have 4 electron pairs, right? So what I'm going to do is I'm going to go over to this chart, which I have already memorized. Well, I'm assuming that you have already memorized. So when I have central atom that has 4 electron pairs around it, that has 3, like in this case we have 4 atoms around it. So the shape was tetrahedral and the bond angle was 109.5. So remember here that we've said that for each lone pair the bond angle is going to decrease by 2.5. So here I have total 4 electron pairs. So the bond angle should start off with 109.5 degrees, because for 4 lone pairs, because for 4 electron pairs, we use 109.5. So, but we have 1 lone pair, so I'm going to subtract 2.5 degrees, and then I'm going to get 107 degrees. So the bond angles in NH3 is 107 degrees. So if we imagine this is how it should look, because the lone pairs are repelling the bond pairs and pushing them down, squeezing them down. So the angle between these bond pairs are 107 degrees, right? So this shape looks like a pyramid, right? So that's why NH3, the shape is called pyramidal. So we're going to look into other bond pair related problems in the next part.